Hello everyone, I'd like to welcome you to this video titled Solving Area Equations, and you will need to get out your Go Math book and turn to page 383. Get out your math journal, pencil, and a calculator. Now the goal for this video is for you to understand how to solve area equations and look at how do you use equations to solve problems about the area of rectangles, parallelograms, trapezoids, and triangles. So let's look at the problem on page 383. It says problem solving using the area of a triangle. Now, it's important to understand whenever we see a problem like this that we need to remember the formula for area of a triangle, which is area equals 1/2 times the base times the height. So we can see, for example, one, it says the Hudson High School wrestling team won the state tournament and has been awarded a triangular pennant to hang on the wall in the school gymnasium. The base of the pennant is 1.5 feet long and has an area of 2.25 square feet. What's the height of the pennant? So the first thing you want to do for a problem like this is you want to write out the formula. Area equals 1/2 times the base times the height. And now whenever you're given the area to a problem and we're trying to find the missing measurement, what we need to do is we just plug in all the information that we have to see what we're missing. So we see the area is 2.25 square feet. That means 2.25 is going to equal 1/2 times the base, we know that, times 1.5 times the height. And now our next step is to work out the problem on the right side of our equation. So we take 1/2 and we multiply it by 1.5, and that's going to give us 0.75. The height stays the same, and then we have 2.25 equals 75 hundredths times a number. Now, what we're doing is we need to get h all by itself. We need to get the height all by itself. So what we do is we divide both sides by 75 hundredths. After we've worked out all of our numbers there on the right side, divide both sides by 75 hundredths. That brings down our height. And we have 2.25 hundredths divided by 75 hundredths is going to equal 3. So what's the height of the pennant? The height of the pennant is 3 feet. Now a way to go back and check this is just plug in 3 for the height, work the problem out, and you'll be able to see that you get 2.25 hundredths for your area. Okay, but we weren't trying to find area, we were trying to find that missing height there within our problem. So let's look at the problem on page 384. It says writing equations using the area of a trapezoid. So it says you can use the formula for area of a trapezoid to write an equation to solve a problem. So what we have here is we have a garden in the shape of a trapezoid has an area of 44 4/10 square meters. That's important to remember. One base is 4.3 meters long and the other base is 10.5 meters long. The height of the trapezoid is the width of the garden. How wide is the garden? So since we're dealing with the trapezoid, the first thing we're going to do is write out the formula. Then from there, we're going to plug in all the numbers that we have. So we know the area is 44 4/10. We know the half is going to stay the same. We don't know the height, but we do know the base 1 and base 2. So 4.3 and 10.5. So that's what we know. Now we're taking all the numbers that we know and we're going to work it out until we just have the height remaining and one number on the right side of our equation. So we add 4 3/10 plus 10 5/10. That's going to give us 14.8. And now we have 44 4/10 equals 1/2 times our height times 14 8/10. Now, obviously, we cannot multiply a half or the height by 14 8/10 or by 1/2. So what we do is we take the 1/2, multiply it by 14 8/10. That's going to give us 7 4/10 times our height. And we know the area just drops down again. And now that we've worked everything out on the one side of our equation, and we just have one number and the height remaining, what we do now is we take 7 4/10, divide it by both sides of our equation. We bring down our height. So 44 4/10 divided by 7.4 is going to give us a height of 6. Okay. Now remember, within the problem it says the height of the trapezoid is the width of the garden. How wide is the garden? So we can see that the garden is 6 meters wide. So now we're going to take a look at solving multi-step problems on page 385. And we have the example 3 at the top. It says John and Mary are using rolls of fabric to make a rectangular stage curtain for their class play. The rectangular piece of fabric on each roll measures 2.5 feet by 15 feet. The area of the curtain is 200 square feet. What is the least number of rolls they need? So the book does a really nice job of going through the different steps that you want to take in solving a problem like this. So the first thing you want to do is analyze the information. You want to rewrite the question as a statement. What this does is this helps you focus in on what you're going to need to find. So the question is, if the area of the curtain is 200 square feet, what is the least number of rolls they need? So basically what you need to do, you need to find the least number of rolls of fabric needed to cover an area of 200 square feet. And then also we want to list the important information. Some of the important information: each roll of fabric is 2.5 foot by 15 foot rectangle, and the area of the curtain is 200 square feet. Do we really care that they have to make one for their class play? Well, we really do, but it doesn't really matter for our problem here. Now we need to formulate a plan. So you write the equation to find the area of each roll of fabric. And we can see, and we want to use the area of the curtain and the area of each roll to write an equation to find the least number of rolls. So the first thing we do, find the area of each roll of fabric. So it's 15 times 2.5. So that gives us 37.5 feet squared for each roll of fabric. Now, it's important to understand that that's not what they're asking. They're asking, if the area of the curtain is 200 square feet, what's the least number of rolls they need? So what we do is we take this 200 square feet and we divide it by 37.5. Why by 37.5? Because that's the area of each roll of fabric. And that's going to give us 5 1/3. Okay, now, is 5 1/3, can we do that necessarily? Is that we can cut maybe a third of one, but they're not asking that. They're asking what's the least number of rolls they need. Okay, so we can't say 5. We're not rounding this to the nearest whole number. We need to understand that 5 1/3, if you just have 5, you're going to have a third left over. So we can see that that John and Mary will need 6 rolls of fabric to make the curtain, because 5 would not be enough, so they need 6 total. All right, so you can even justify this answer. So each roll is about 38 feet squared. So since 38 feet squared times 6 is 228, the answer is a reasonable answer of needing 6. So those are some steps that you can take when you're looking at solving some multi-step problems with area. So let's take a look at the problem on page 386. It's number 1. So it says a triangular bandana has an area of 70 square inches. The height of the triangle is 8 3/4 inches. Write and solve an equation to find the length of the base of the triangle. So let's do this one together. And you can write the formula first of all. And then after that, you want to plug in the numbers that we know. So we know the area is 70. We know the height is 8 3/4, but we don't know the base. So we have equals 1/2 times the base times 8 3/4. Now our next step of what we need to do is we cannot multiply 1/2 times b or b times 8 3/4. So what we do is we take 1/2 and multiply it by 8 3/4. And 1/2 times 8 3/4 is going to give us 4 3/8. And then we have 70. And then now what we do to both sides of the equation, we're going to divide by 4 3/8. And that will bring b down all by itself, the base down all by itself. And then divide this by 4 3/8. And that's going to give us 16 for our base. So what you want to write in for number 1 is just 16 inches. It's not squared inches because it's just finding the base. So I would like you to do number 2 all on your own. So this deals with the trapezoid. You'll need to write out the formula, plug in the numbers, and work it out. When you press play, I will have the answer for you. So pause the video now. Okay, so you can see the answer that I have 28 centimeters would be the width of the desk. Remember, the height is also the same as the width of this desk. So you can see my work where I wrote out the formula for trapezoid and plugged in my numbers, and then eventually got 28 centimeters. Okay, so let's take a look at number 3 together. On page 386, it says Taylor wants to paint his rectangular deck that is 42 feet long and 28 feet wide. It says a gallon of paint covers about 350 square feet. How many gallons of paint will Taylor need to cover the entire deck? So let's work through this problem. So the first thing we need to do is realize that we need to figure out how many gallons of paint Taylor would need to cover the entire deck. And we need to write an equation to find the area of the deck first of all. So let's write that in, area. We know that area is length times the width. So we take 42. So area is going to equal 42 times 28. And let's write this down together. That's going to give us 1,176 feet squared. Now, it's important to understand with these multi-step problems that they are multi-step. And a lot of times we think, well, we found the area, then we should be finished. But we're not. Now the next thing because they're not asking us, we back up, they're not asking us what's the area. They're asking us how many gallons of paint will Taylor need to cover the entire deck. Now what we need to do, we need to write an equation to find the number of gallons of paint. So I want you to write that in. And now it says write and solve the equation. So what we have here is we take our area is 1,176, and we're going to divide it by 350 square feet. Where am I getting that from? Because we know a gallon of paint covers 350 square feet. And that's going to give us 3 36/100. All right, so you cannot go to the store and buy 3 36/100 gallons of paint. You usually have to buy it by the gallon. So we know that Taylor will need to buy 4 gallons of paint. So it can be very easy to think that you need to just round it to the nearest whole number, but whenever you have anything above, even if it was 3.01, you'll still need to buy 4 gallons of paint. So this concludes the video on solving area equations. If you have any questions about this concept, please come and see me.